Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, uGobela Wemets, Abudiwa Source. Right. So in today's lesson, we're going to be looking at geometric sequence and series. And then without any further ado, let's look at this question that we have here. Okay, so 3.1 says if R is equals to 1 over 5 and A is equals to 2000, determine Tn, the general term of the series. Now, what type of series is this one? We can say that it is a geometric series, mainly because we have R here, right? So the series that contains the common ratio is obviously the geometric series, right? So in order to write our Tn, we just go Tn is equals to A, R, n minus 1. So this formula is given in your formula sheet. Then what's your A? We are given that A is 2000. So we're just going to substitute 2000 and then our R is 1 over 5 to the exponent of n minus 1. So that's your Tn. It's only a mark. So that's what you were expected to do. Now 3.1.2 says calculate T7. So all you need to do here is substitute 7 where there's n, right? And then now you have 2000 and then 1 over 5 to the exponent of what? 7 minus 1. So when we substitute our 7 there, our value is supposed to be, punch that in your calculator, that's 16 over 125, right? So that becomes your value there, right? 16 over 125. And then 3.1.3 says which term of the series will have a value of 16 over 15,625. So we know at this point, what we need to do is equate our general term to this value here. So remember, we have Tn is equals to 2000, 1 over 5, n minus 1. So all we have to do here is substitute the 16 over 15,625, and then we say equal to 2000, 1 over 5, and then n minus 1 like that. Now, at this point, we know that we cannot take this 2000 and multiply with that 1 over 5. So what we are supposed to do here is multiply by the reciprocal of 2000. So we're going to multiply by 1 over 2000. Or we can just simply divide both sides by 2000, right? So remember, multiplying by 1 over 2000 is similar to just dividing by 2000, right? Now, if you do that, the value that you're going to end up with is 1 over 195 and then 3125. Then that is equals to 1 over 5 to the exponent of n minus 1. Now, at this point, we can go ahead and try to write this in exponential form. So if we take this number here and then press it into our calculator, equal sign, then shift fact, then that will give us 5 to the exponent of 9, right? Then we can write all this as 1 over 5 to the exponent of 9, and then is equals to 1 over 5 to the exponent of n minus 1. Now, at this point, look at this. We have the same basis, right? So the law of exponent says if we have the same basis, we can drop down the exponent. So that means we have 9 is equals to n minus 1. Now, looking for n, we can take this negative 1, transpose it over to this side. Now, this is n plus 1, 9 plus 1, that's equals to 10, right? So which term of the series will have a value of 16 over 15,625? It is the 10th term, right? It is the 10th term. Now, let's proceed. We have 3.2 says consider the geometric series where we are given the sum of Tn, the sum to infinity of Tn, running from n is equals to 1 all the way to infinity is 27, and then we are given S3 is equals to 26. Then it says calculate the value of the constant ratio R of the series. Now with this thing here, I want you to understand this. If we are to express this in terms of the sum, you need to note this. If we are writing T1, remember we have the formula Tn is equals to AR n minus 1. If we were to express T1, the T1 is just simply equals to A, because we'd have to say A r to the exponent of 1 minus 1. The r1 minus 1 will give us ar to the exponent of 0, which any variable or number expressed to the exponent of 0 is just 1. So our t1 will end up just being a. If we wanted to express t2, this would be ar 2 minus 1. So we'll end up with t2 is equals to ar. If we wanted to express t3, this is ar to the exponent of 3 minus 1. And then our t3 would be ar to the exponent of 2. Right. Now remember, S3 means the sum of 3 terms. Meaning, in other words, we can express S3 as T1 plus T2 plus T3. Remember, S3 means the sum of the first 3 terms. So the first 3 terms are represented by A, and then your T2, remember, is AR, and then your T3 is AR squared. So what you need to understand here is that you will need to change all this and write it in mathematical form. Right. So the S3 is just S3, but then when you write it like this, now you can be able to find the value of A and then afterwards find the value of R. Right. So let's continue with that. Now that we can see that, let's try to express the sum to infinity there, which is equal to 27. So we have sum to infinity. We know the formula for sum to infinity is this. So it says sum to infinity is equals to A over 1 minus R, where our R obviously is not equals to 1. Now the sum to infinity we've been given, that is 27. Remember, this number that we see here is the sum, right? Now because we have infinity here, this means the 27 is our sum to infinity. So we should substitute it here. We have 27 is equals to A over 1 minus R. Now at this point, we can cross multiply this. We'll have 27 and then in brackets 1 minus R. Then this is equals to A. Now we have formulated this equation. Let's call it equation number 1. And then we've formulated another equation. Let's call it equation number 2. Now we can see that this expression here is expressed in terms of A, and then this one here. So A here is the subject of the formula. That means we can come here and substitute this expression wherever we see A. But then before we do that, we can see that A here is a common factor in between all these terms. So let's factor out the A. We'll have A, and then this would be 1 plus R, and then plus R square, right? So we have A expressed out, taken out as a common factor. Then if we take out the A here, we are left with 1. And then if we take out the A from this one, we are left with the R. We take out the A from here, we are left with R squared. Okay, so let's go ahead and just call this one here equation number 1. So that means at this point, what can I do? I can substitute this expression here in equation number 1. So substitute equation number 2 into equation number 1. So what does this mean? Where I see A, I will substitute this expression 27 bracket 1 minus R. Okay, so let's do that. So that means I will have, so writing it here, this will be S3. So remember our S3 was 26. So let's substitute before that. So we have our 26 here, 26. And then this would be 26 is equals to, what is A? That's 27. And then 1 minus R. And then here I have 1 plus R square. Now you can see what I did in the position of A. I substituted this expression, this whole expression. Then at this point, let me try to divide both sides by this 27 so that I get rid of it. So divided by 27. So I have 26 divided by 27. Now this is a 26 over 27 is equals to this whole expression here, which is 1 minus R and then 1 plus R square. Right. Now, at this point, what can I do? Let me try to multiply inside with this, right? So to continue, let me just write it here. Okay, so continuing from that part, we have the 26 over 27 is equals to, so if we say 1 multiplied by 1, that's 1. And then we have the 1 multiplied by r, that's r. 1 multiplied by r squared is r squared. Now let's multiply with the negative r. If we say negative r multiplied by 1, that's minus r. And then negative r multiplied by r, that's a minus r squared. And then we have minus r multiplied by a positive r squared. That's minus r cubed, right? So now we have 26 over 27 is equals to, look at this now. This will cancel out with that. This will cancel out with that. So we are left with 1 minus r cubed, right? Now at this point, what can we do? If we have this, let's take this r cube over to this side. So this would be positive r cube. Then we'll have 1 minus 26 over 27. Right. So I just took this one over to this side and then took that one over to that side. Then this is r cube is equals to, now if we punch that in your calculator, that will give us 1 over 27. Now at this point, we are looking for r, so we can cube root to get rid of this cube there. So if we cube root both sides, our r is equals to 1 over 3, right? And just like that, you would find your value for r, right? So that was pretty much a stretch, but then if you can just slowly try to understand what I did there, it's all just a matter of applying your maths here and then just understanding how to change all this into mathematical expressions. So make sure to just pause throughout the video and just try to understand how I went about solving that question. Then let's proceed to another question. We have question 3. It says the following geometric series is given. We have 4, 12, 36, and then all the way up until 15 terms, right? So it says 3.1.1, write the series in sigma notation. So every time we are required to write in sigma notation, what we should actually find is the Tn, the general formula, right? So this is a geometric series, so we must find the nth term or the general formula for the arithmetic series. Now, what we need to do here is substitute in our A and then calculate the value for r. So we know r is equals to T3, T2 divided by T1 and also T3 divided by T2. So that's 12 divided by 4 or 36 divided by 12, which both of them will give you 3. So this confirms that your common ratio is 3. So we have 3 here. And then also that's pointed of n minus 1. So that's our Tn. Now, having to write our sigma notation, this is what we do, right? So we say n must start from 1, because remember, when we substitute here, we start with 1, and then it must run all the way to what? 15, because we have 15 terms. So we must have 1 here and then 15 there. And then this would be 4. And then multiplied by 3n minus 1. So that's how you write this in sigma notation. So this is the sum of Tn4 times 3 to the exponent of n minus 1, running all the way from n is equals to 1 up until 15. So that means we have 15 terms there. Right. Now, 3.1.3 is asking, is this series convergent? Provide a reason for your answer. Now, looking at our r value just here, we can see that r is equals to 3, but then in order for a series to converge, remember the condition for a convergent series is that r must always be between -1 and +1. So your r must be an element of -1 to +1. So we'll say, why is this not a convergent series? So we are supposed to say no. No, it is not a convergent series. Then r is equals to 3. It is not in between. It is not in between -1 and 1. Or you can say it is not an element of -1 to positive 1. So had our R being something like maybe say 0.5, then we'd say it's convergent because it will be within these values. But then now that it is outside these critical values, we say the series is not convergent, right? So I hope that makes sense there. Did I skip a question? Oh, yeah. 3.1.2. Right. I think I skipped that one. So this one was saying calculate the series, right? Calculate. So this is calculate the series, meaning calculate the sum of the series. So pardon me for skipping that one. I was just rushing for that there. So, okay, to calculate the sum, it's pretty much simple, guys. All you just have to do is write the formula. We have Sn is equals to, this is A, and then we have 1. We have Rn, r to the exponent of n minus 1, and then this is r minus 1. And then this will give us what is our A here. So our A value is supposed to be 4. And then our R, remember we calculated it was 3. But then how many terms do we have? 15. So minus 1. Then here we have 3 minus 1. Right. So it's just a matter of having to punch all that in your calculator. So let's see, when we punch that in our calculator, what does it give us? A very, very big number. So that's 28,697,812, right? So 28,697,812. It is to be expected. So don't have that fear for big numbers, and then you kind of think that what you did here is incorrect. It is to be expected. Remember, I said that it is to be expected when we are dealing with geometric series to have such big numbers, right? Then 3.2 says the sum of an infinite geometric series is 13.5. Now note this, whenever they tell you that a geometric series is infinite, that means whatever value that they give you there for the sum is actually the sum to infinite. So they say the sum of an infinite geometric series is 13.5. That means your sum to infinity is 13.5, right? Now they mention where your R is not equals, should not be equals to 1, because we know if your R is equals to 1, then this whole thing falls off, right? Because it will be undefined. Then now they're saying the sum of the same series, the very same series that we have here, is now calculated from the third term. So instead of starting from term number 1, they started from term number 3. Now I want you to pay attention to this. Remember, we said that term number 1 is expressed as A. Term number 2 is expressed as AR, and then term number 3 is expressed as AR square. Right. So this first one here that gives us 13.5 started from A, right? So that means if we are to express our sum to infinity here, we say sum to infinity is equals to A over 1 minus R, where our R is not equals to 1. Then what is sum to infinity is 13.5. And then since our first term is just A, we just substitute A here, then over 1 minus R. Now we can express this in terms of A by just cross multiplying this. This will give us 13.5, and then bracket 1 minus R is equals to A. Let's call this equation number 1. But then now what did they say here? The sum of the same series is now calculated from the third term. So if we are to do this equation once again, we'll say sum to infinity is A over 1 minus R, but our A this time will be represented by AR squared. Why? Because they said this series here is starting from term number 3. So that means you'll no longer have A, you'll have the third term, which is AR square, right? So you have AR square here because this series here is starting from term number 3. That means they excluded the first 2 terms. They excluded this one and that one. So now your series is starting from AR square. Then we have over 1 minus R, where we know that your R must not be equals to 1. Then what is your sum to infinity? They said if we are excluding the first 2 terms, then our sum to infinity is only just 1.5. So we have 1.5 is equals to a r square over 1 minus r. Now, what can we do? Let's cross multiply here. We'll have 1.5. 1 minus r is equals to ar square, right? So if we are to express this in terms of a, so this would be 1.51 minus r is equals to a, and then divide both sides by r, this r squared. This would be a is equals to 1.5 1 minus r over r squared. Let's call this equation number 2. Now we can see that equation number 1 and equation number 2, they're all expressed in terms of a. That means we can just equate equation number 1 and equation number 2, right? So equating those ones, let's see. So now we have seen this, we have seen that. Let's try to erase here. So we have 13.5 and then 1 minus r is equals to a. We said this is equation number 1. And then equation number 2 was in the form of a, was in the form of 1.5, 1 minus r over r squared is equals to a, and then we said equation number 2. Now we must say equate equation 1 and equation number 2. So since they are both expressed, since they both have a as the subject of the formula, so that's 13.5, 1 minus r, and then is equals to 1.5, 1 minus r, and then over r square. Now, since we can see that 1 minus r and 1 minus r is common, we can just go ahead and deal away with that by multiplying both sides by 1 over 1 minus r. So this will just cancel off that. Then we have 13.5, but then if we cross multiply with r squared, we have 13.5 r square, and then here we'll be left with this 1.5. Now at this point, divide both sides by 13.5. So we have 1.5 divided by 13.5. That's equals to r squared is equals to 1 over 9, right? Now we know in order to calculate r, we must get rid of this square by putting a square root both sides, right? So it's a square root. Let me take off the 2 there. So this will give us r is equals to 1 over 3, right? Plus minus 1 over 3. But then remember, the condition was our r needs to be greater than 0, right? Our r needs to be greater than 0. So hence we have r is equals to, so we can start by saying plus minus 3, and then we conclude our r must be positive 1 over 3. Because remember, r greater than 0 means your r needs to be positive, right? And just like that, you would have calculated the value for r. So also with this one, guys, try to take it slow, one step at a time, and just try to understand the approach that I took solving this question here. It is not tricky. It's just a matter of you having to understand how to express this in mathematical form. And then from there, it's just your mathematics, right? So just try to understand the approach. Now, 3.2.1 says, hence determine the first 3 terms of this series. Now that we have our r, we can use this r here to calculate the value of a, right? So we can just substitute it to equation number 1. So let's clear the screen. And then if we are to substitute, we have 13.5, 1 minus r is equals to a. If we are to substitute the value of r here, this is 13.5, 1 minus 1 over 3, and then it's equals to a. Remember, a is the first term. So if we calculate that one there, our a is supposed to be equal to 9, right? So if you just punch all this in your calculator, that's 9. But then remember, our r is equals to 1 over 3, meaning if we have 9 here, in order to find the next term of the sequence, we only need to say 9 multiplied by 1 over 3. So if we say 9 multiplied by 1 over 3, that's 3, right? And then if we say 3 multiplied by 1 over 3, that's 1. So the first 3 terms of this series are 9, 3, and 1. So I'm writing it as 9 plus 3 plus 1 because remember, it is a series, right? It is a series. Now, let's proceed. Question 2 here says we are given the geometric series 1 over 5 plus 1 over 15 plus 1 over 45. Now they're asking, is this a convergent geometric series? Justify your answer with a necessary calculation. So all that we need to do here is calculate our value for R by saying T2 divided by T1. And then also you can say, just to confirm, T3 divided by T2. But if we can only take this one, it will just be enough because we are already told that this is a geometric series. So if we say 1 over 15 divided by 1 over 5, this should give us 1 over 5 multiplied by 5 over 1. So the value that we'll get here is 1 over 3, right? Now 1 over 3 is in between -1 and +1, right? So this is a 1 over 3 is an element because 1 over 3 gives you something like 0.333. Then this is in between the critical values -1 and +1. So we can say yes, it is convergent. Why? Because our R is an element of -1 to +1. So the value of R that we get is in between those critical values, right? So that's all you needed to do there. Now, let's check. 2.1.2 says calculate the sum to infinity of this series, right? Note, if they say a geometric series is convergent, the question that usually follows is for you to calculate the sum to infinity, because a convergent geometric series in most of the time always leads to infinity. Then this is sum to infinity, and then we have a over 1 minus r, and then where your r should not be equals to 1. So what is your a in this case? We can see it's 1 over 5. So we just go 1 over 5 all over 1 minus r. So our r, we just calculated it to be 1 over 3. So all you do is just punch this in your calculator, but then be careful how you punch it. What I prefer is you to just write 1 over 5, and then you just go divided by in bracket 1 minus 1 over 3. So this is quite simple to do, instead of just having to put fractions on top of fractions, which might be a bit complicated, and then if you don't punch your calculator very well, you might end up with an incorrect answer. So try to break it down like this: 1 over 5 divided by, in bracket, 1 minus 1 over 3, right? Then this will give you 3 over 10. Right, so your sum to infinity is equals to 3 over 10, right? So both of those were just 2 marks, so easy to get. Now, 2.2, we are told of an arithmetic and geometric sequence are combined to form the pattern, which is given by Pn is x 1 over 3, 2x, and then now looking at this, you can see that this is how they combine this. So they put a term arithmetic, and then they put geometric here, they jump arithmetic, geometric, and then arithmetic. So that's how they combine those. So looking at this is x, 2x, 3x. You can tell that this here we have a common difference of just x. But then looking at this, we can see that with this one we have a common ratio here, right? So our common ratio is it 1 over 3? Yes, our common ratio is 1 over 3. Now, 2.2.1 says write down the next 2 terms of this pattern. Now, we do understand that considering how the pattern has been formed here, we know that the term that follows here should be the one that is in arithmetic. So this should be 4x. But then the one that follows here, we are supposed to say 1 over 2 1 over 27 multiplied by 1 over 3. So that should give us 1 over 81, right? So if you say 1 over 27 times 1 over 3, 27 times 3, that's 81. So that's 1 over 81. So the next two terms are 4x and 1 over 81. So that's for 2 marks. Then 2.2.2 says determine the general term Tn for the odd terms of this pattern. Write down your answer in terms of x. Now for the odd terms, when they're talking about the odd terms, they're talking about all the terms that are in odd positions, meaning position number 1, position number 3, position number 1, 3, 5, and then 7, right? So this is how you are supposed to do that. So in other words, when they say for the odd terms of this series, they're speaking about the what? The arithmetic sequence, or the arithmetic, the arithmetic sequence in this case. So how do we write the general formula? We are supposed to write it in terms of x. So let's go and write out the values. That's x, 2x, 3x, and then 4x. We know that the difference here is just a positive x, because all this, if you can just add x to get the next term. So that represents our d. Now the formula, remember, is Tn is equals to a plus n minus 1d. So what is our a? Our a is x, then plus n minus 1, and then what is our d? It's also x. So this would be x plus x times n, that's xn, and then x multiplied by -1, that's minus x, right? Now at this point, we can see that this x and this negative x will cancel out. So that means my Tn is only equals to xn, right? So that's my solution. So it was only 2 marks. So your Tn is equals to x multiplied by n. And then just like that, you are done. Now, let's proceed. Now for 2.2.3, it says calculate the value of P26, right? So P26, we can tell that the P26 will be part of the geometric series, right? Now understand this, right? So P26, if we are to consider in terms of the even term patterns, right? So the terms in even positions, we would find that our P26 is actually 26 divided by 2. We'd find that in respect to the geometric series, P26 is actually the 13th term of the geometric series, right? Of the geometric series or sequence. Why? Because remember, this is in position number 2. We skip here. It's in position number 4. We skip. It's in position number 6, right? But then in terms of the geometric series, this is in term number 1, term number 2, term number 3, which is why I'm saying 26 divided by 2, because I'm trying to get the term number in respect to the geometric sequence. So our P26 will actually be representing the 13th term of the geometric series, right? Hope that makes sense. Then in order to find that, calculate the value of P. So in my case, I'll just be calculating the value. Let me just express here the series as T, right? Tn. So the geometric series would be Tn. So that means I'm looking for T13. So this would be A, R to the exponent of n minus 1. What is my A? That's 1 over 3. What is my R? It's also 1 over 3 as well. But then I'm not going to come here and substitute 26. I will substitute 13 instead, because in respect to the geometric sequence, it's in the 13th position, right? Then when I do that, that gives me 1 over 1,594,323, right? So when you punch that in your calculator, it gives you that, right? So it gives you a value like that, or it gives you in a scientific form as 6.27 times 10 to the exponent of -7. So it's either you get that one or you get this one here. Either way, it's correct, right? So that's all you were supposed to do for that one. So it's only, how many marks was that? Only 3 marks, right? So yeah, 2.2.4 says if n is running all the way from 1, and then here we have 21, so that means we are dealing with 21 terms, then they're saying Pn is equal to 33.5. Now determine the value of x, right? So how are we supposed to determine the value of x? We have 21 terms, right? Now from this 21 terms, if we are to consider all the odd terms, right? So that means 21 will have 11 odd terms that are in the odd positions, right? Which will be representing your arithmetic, right? So this would be representing your arithmetic sequence, right? So if you are to consider it, let's mark X for the ones that are arithmetic, and then let's mark plus for the ones that are geometric. So if you were to do that and continue with that pattern, you'd find that your axis will be 11, and then your plus signs would only be 10. So your plus signs are representing the geometric. Now, if you add this 11 terms that belong in the arithmetic sequence and 10 terms that belong in the geometric sequence, all form 21 terms, right, from this given sequence. Now, if we know that, that means we can calculate the sum of 11 terms of the arithmetic sequence, then calculate the sum of 10 terms from the geometric sequence, and then add them together, right? Now, if we add them together, the S11 and S10 is giving us what? 33.5. So they already gave us the sum. So all that we have to do here is to calculate the value of x, because that's what we don't have, right? So, okay. Let's deal with that question there. So to deal with that question, first of all, let's calculate the sum of the 11 terms of the arithmetic sequence. So that means we have n over 2, and then we have 2a plus n minus 1, and then d like that, right? So what is our n? We have 11 terms, so that's 11 over 2. And then here we have 2. What is our a? It's x. Right, then we have plus. Now if we say 2x plus 10x, that should give us 12x, right? So we have 11 over 2, and then add them together, that's 12x, right? So now when we have that, let's calculate the sum of the 10 terms of the geometric series. So we will have a 1 minus rn, and then over 1 minus r, where our r should not be equals to 1. What is our a? It's 1 over 3. Then we have 1 minus r to the exponent of what? So what is our r? We said, again, it's 1 over 3. And then to the exponent of 10. Because remember, for the geometric, we have 10 terms. Then this would be 1 minus 1 over 3. If we calculate that, punch all that in your calculator, that is supposed to give you a 0.5. So punch all that in your calculator. Okay, then now remember, when we add this 2, we said if we add S11 plus S10, so S11 of the arithmetic and S10 of the geometric, they should give us what? 33.5. Because now it is the sum, it is the sum of the first 21 terms. Now from this, what do we get? 11 over 2 multiplied by 12x. Remember, 11 over 2, that's 5.5. So if we say 11 over 2, say 11 over 2 multiplied by 12, right? So that's supposed to give us 66x. So let's write this one. This is 66x. So in other words, we are supposed to say 66x in terms of this. 66x plus 0.5 is equals to 33.5. Now, what can we do? Take this 0.5 over to this side. So we have 66x is equals to 33.5 minus 0.5. So we have 66x is equals to what? 33. Then we can divide both sides by 66. Then our x is equals to 1 over 2. Right. And just like that, you would score your 6 marks. So also with this question, take your time to understand the approach that I applied having to solve this question here. So just take it one moment at a time, pause through the video and just try to understand whatever that I did here. Right. So yeah, the stakes are very high with the questions that we are doing. Remember, guys, with this channel, we are just trying to push to those questions that would mostly give you a challenge in your question paper. So we are doing it for those quality level 7s so that nothing ever comes as a challenge to you. So remember, if you stretch your mind to do such questions, then you put yourself at a position whereby you can tackle a lot of questions and score very good marks in this topic, right? Then we have question 2 here. It says, given the geometric sequence, we have 9 over 2 and then 9 and then 18. Then we are given the last term here, 2,304. Now 2.1.1 says, determine the value of R, the common ratio. So we know the common ratio can be calculated by saying T2 divided by T1. So we have 9 divided by 9 over 2, right? Or you can simply say T3 divided by T2, which would be much simpler given that both these values here are natural numbers. 18 divided by 9, this would give us 2. So even with this one, you would find that it's 2. 9 divided by that, you'd say 9 multiplied by that, and then cancel, this would be 2, right? So the value for R, only for a mark, is equals to 2. Now, how many terms are there in the sequence? Remember, with this question, we said if you are given the value of the last term there, you can actually find how many terms are there in the sequence by calculating the position of the last term. So if you calculate the position of the last term, you find that position, then you can conclude that the number of terms are equivalent to that term number there. So let's do that. We have Tn is equals to ARn minus 1. For our Tn, we're just going to go ahead and substitute this value. That's 2,304. And then A is 9 over 2. Our R was 2. And then we have n minus 1. Right. Now, at this point, what is it that you must do? You cannot multiply this one, but then you can do this. You can try to get rid of this by multiplying both sides by its reciprocal. So if we multiply, let's say 2,304 multiplied by 2 over 9. So this gives us 512, right? So we have 512 is equals to 2 to the exponent of n minus 1. Now we know we are dealing with exponents, so we must express that 512 in terms of exponents. So shift fact, we have 2 to the exponent of 9, right? So the 512 is 2 to the exponent of 9, and then 2 to the exponent of n minus 1. Now, let's see this. The bases are the same. That means we can drop the exponents. So we have 9 is equals to n minus 1. If we take this negative 1 over to the side, then that's 10. So n is equals to 10. So that means how many terms do we have? We have 10 terms, right? So just like that, that's what you're expected to do. Only 2 marks. Then 2.2 says, given again sum to infinity from k running from k is running from positive 1 all the way to sum to infinity. That means the 12 here is the sum to infinity. So sum to infinity is equals to 12. Determine the value of m. So what are we supposed to do? First thing that you need to do when we are given this, try to at least find the first 3 terms, right? So by substituting in the k here, the k values, so you will start from 1 and then you substitute the 1, then you go ahead, substitute 2, and then you substitute 3, just like that. So if you substitute 1, this would be 1 minus 1. So it's 0. So if you were to start, and then you have 1 minus 1, that's 0. So that means you'd only end up with 6 because m to the exponent of 0 is 1. So 6 times 1 is 6. Then for the second one, then you go, this is 6m, 2 minus 1. So this would give you 6m, right? Then for the third one, this would be 6, and then you have m, 3 minus 1. So this would be 6m square. Right. Now to calculate your value for R, you'd have to say R is equals to T2 divided by T1, which would be 6m divided by 6. So that means your R is equals to m, right? So writing the sum to infinity, we have sum to infinity is equals to A over 1 minus R, and then where R should not be equals to 1. So sum to infinity is equals to 12. What is our A? Our A is just 6. So we substitute 6 here. Then 1 minus R, remember, is equals to m. So we substitute m here. Then if we cross multiply this, that's 12, bracket 1 minus m is equals to 6. Let's just divide both sides by 12, like that. So we have 1 minus m is equals to 1 over 2. Then bring over the m to this side. That's 1 minus 1 over 2 is equals to m. Then 1 minus half, that's m is equals to 1 over 2. Right. Then for 2 marks, that's all you were expected to do. Now you can just go on crying and saying that they're very stingy with the marks. But then all this, they just expect you to know it. So these are basics, guys. That means you must not really focus much on the basic for these questions, because you can see they're not awarded many marks. So you don't get awards for just knowing the basics. You have to stretch yourself to really know those questions that will give you proper marks, right? Okay, then in 2.3, we are told that the third term of a geometric series is 18 and the fifth term is 162. Determine the sum of the first 7 terms where R is less than 0. Right. Now, understand this. This involves you having to know how to write this. So if you are given word problems like this, all you have to understand with this type of questions is how you change all this to mathematical language, right? So term number 3, remember we said if we are to express T1, this is A, T2, that's AR, and then term number 3 would be equals to AR to the exponent of 2, right? So now let's do that. So we have term number 3, it's 18. So that means in other words, we can say AR square is equals to 18. Remember, AR squared, this represents term number 3. Then we are given the fifth term is equals to 162. The fifth term will be represented as AR to the exponent of 4, which is equals to 162. Now at this point, let's call this equation 1 and call this equation 2. We can say equation number 2 divided by equation number 1, right? So that means we will end up with AR to the exponent of 4 over AR to the exponent of 2 is equals to 162 divided by 18. So I'm taking this whole expression divided by that. And then it's always the one with the big exponent over the one with the small exponent. So the A and A here will cancel out. But then what will happen here? We are dividing, the bases are the same. So we have to subtract the exponents. So that's R squared. But then what is 162 divided by 18? So that gives us 9, right? Now, if we are to square both sides, then our R is equals to plus minus 3. But then let's look at the condition where R is less than 0. So that means your R must be negative. So our value for R here will be equals to negative 3, right? Now that we have the value for R, we need the value for A, because in order to calculate the sum, all you need to have is the value for A and the value for R. So now we can take this R here and substitute it to any equation. Let's just substitute it to equation number 1 because it is simple. Then that's a, and then where there is r, negative 3 over to the exponent of 2, and then I have 18. So this will give me 9. So that's 9a is equals to 18. If I divide both sides by 9, my a is just equals to 2. Right. So that's a very nice question there. So my a is equals to 2. Now that I have the value for a, and then I also have the value for r, that means I can now calculate the sum of how many terms? 7. So by doing what? Just by saying S7 is equals to, so let me look at my R. My R, I can see that it's less than 1. So the formula that I need is A and then 1 minus Rn, and then over 1 minus R, because R is less than 1. So A is 2, 1 minus, in bracket, negative 3 to the exponent of 7 over 1 minus negative 3, right? So pay attention to those signs. So this is all to the exponent of 7. And then when we punch our calculator there, our sum to 7 terms is equal to 1094. So there you go. There you go. So just by solving that, you'd have yourself a whooping 5 marks. So these are the kind of questions that you should practice more. Then 2.4 says the general term of a quadratic number pattern is Tn is equal to an squared plus bn plus c, and its first term is 8. The general term of the first difference of the pattern is tk is equal to 4k minus 2. So this is nice. They gave us the formula for the first difference. Now they say determine the next 2 terms of the quadratic number pattern, right? So if they say we must determine that, now this is what we can do. They told us that the first term there is 8, right? So the first term of the quadratic pattern is 8. Now remember, we are given what we have here. If we are dealing with this, here we have the first difference. Now let's calculate the first term of the first difference by substituting 1 where there's k. So we'd say T1 is equals to 4. 4 times 1 minus 2, that's equals to 2. So that means our first term of the first difference would be 2. So in order to find the second term here, I would have to say 8 plus 2, and then it will give me 10. But then remember, the first difference is not the one that is constant, right? So we need to find another term here by saying what? T2. So we are calculating the second term of the first differences. Then 4 times 2 minus 2. 4 times 2, that's 8 minus 2, that's 6. So here we are supposed to have 6. Then if we say 10 plus 6, it will give us the term here, which is 16. So that's how you were supposed to do it. So that means your terms here are 10 and 16. Right. So just like that, you find that. Now, 2.4.2 says, hence or otherwise, show that the general term of the quadratic number pattern is given by Tn is equals to 2n squared minus 4n plus 10. Easy peasy. Lemon squeezy. So we have 8, 10, 16. And then remember here we had 2. And then we were given 6. Now if we are to look for the second difference, that's 6 minus 2 is equals to 4. Right. Now we have the second difference, the first difference, and the term. We know that this one must be equated to 2a, this one to 3a plus b, and then here to a plus b plus c, right, in order to find this. So if you've watched the previous video that I posted, then you already know this. We did a lot of this quadratic questions. So 2 divided by 2, that's 4 divided by 2, that's 2. So check, our a is 2 here, and then we just found that A is 2. And then 3A plus B, so we have our A is 2 plus B, and then equate it. Remember, we are dealing with the first branch here. We are equating it to the first branch. Then that is equals to what? 2. Then 3 times 2, that's 6. But then 2 minus 6, then B is equals to negative 4n. Look at this. Our B is negative 4. And then, why am I saying n? Negative 4. So B is equals to negative 4, and my B here is also negative 4. Now let's calculate C. So I have 2 minus 4 plus C, and then equate it to this 8 here. So 2 minus 4, that's negative 2 plus C is equals to 8. If I take this negative 2, transpose it over to that side, that's 10, right? So therefore, my Tn is equals to 2n minus 4n plus 10. So it is correct. Then 2.4.3 says, which term of the quadratic number pattern will be equal to 3050? Easy peasy also with this one. So all you have to do is take this general term here and equate it to 3050. So there was really no excuse if you were unable to get this one. All you had to do is just take this same expression here, equate it to this one. So you'd still have this 3 marks here, even if you failed to actually prove that. Then this is 2n squared minus 4n plus 10 is equals to 3050. Then take this, transpose it over to the side. That's 2n squared minus 4n. Then, so if we say 10 minus 3050, that's negative 3040 is equals to 0. Now, everything here is divisible by 2, so let's divide throughout by 2. So this is n squared minus 2n, and then minus 1520 is equals to 0. Now, factorizing this, we know that we can just go ahead and use the quadratic formula, because finding the factors for this one can be pretty daunting. So you just want to press that in your calculator, then write this in terms of factors. So you have your n is equals to 40, and then you also have your n is equals to negative 38. So in terms of factors, you're going to write it as n minus 40, and then n plus 38. So if you write them like that, you get the mark for factors, right? So there's always a mark for the factors. But then you can just, by the side, you don't have to show this quadratic formula. You just do it on your paper there, and then just come here and write this in factors. So they give you the answer for the mark for the factors, and then you just go n is equals to 40 or n is equals to negative 38. Then you are done. So you have the mark for factors, and then you also have the mark for the answers there, right? So now, because we know that our n must be an element of natural numbers, let's not forget that we must come here and cancel off the negative 38, right? Because our position cannot be a negative. So n must always be an element of natural numbers. So don't forget to come here and cancel off that negative 38, right? So that's it with that question. That's how you were expected to solve it. So take your time and try to understand these questions. Remember, guys, if you want these lessons to really work for you, you have to approach them in a proactive manner. So don't just watch the videos, but also try to solve the questions on your own, and then check them against, check your answers against mine on this channel, right? So in that way, you ensure that whatever that you learned here really sticks, right? And then 3.1 says, given that in a geometric sequence, T9 is equals to 768 and T13 is 12,288, determine the value or the values of the common ratio and the first term of the sequence. So we can see that this is still in the same format as the question that we just did previously there. So all you have to understand is how to express T9 in mathematical form. So we already know that our T9 will be expressed as AR to the exponent of 8. And then T13 must be expressed in the form of AR to the exponent of 12. Once you understand this, guys, trust me, you are gone. Right. So now that means we have AR to the exponent of 8 is equals to 768. Let's call this equation number 1. We have AR to the exponent of 12. Let's call this 12,288. Let's call this equation number 2. Now we know that we have to take equation number 2 and then divide equation number 1. So it's always the one with the bigger exponent divided by the one with the small exponent. So AR to the exponent of 12 over AR to the exponent of 8. So we have 12,288 divided by 768. Then this will leave you with cancel. 12 minus 8, that's R to the exponent of 4. Then let's punch that. That's 16, right? So what is the fourth root of 16? So if we fourth root both sides, so fourth root of 16 gives me 2. So R is equals to 2. But then let's look at the condition. Are we given the condition? So in this case, we know that this must be plus or minus 2. So that must be plus or minus 2. And then let's go ahead and try to calculate our A. So having to calculate A, we can substitute in any equation here, equation 1 or equation number 2. Let's substitute in equation 1 because of the smaller exponent there. 8R to the exponent of 8, 768. We want the value of A now, but our R is plus minus negative 2. So either way, it doesn't matter here whether you put a negative or a positive, because after all, this is to the exponent of an even number, so it will come out as a positive. So I can just say 2 to the exponent of 8, then 768, right? And then if we are to do this, 2 to the exponent of 8, that's 256. So we have 256A and then 768. Divide both sides by 256. So my A is equals to 3. My A is equals to 3. So now you found the value of A. Your A is just positive 3, but your R can be 2 or negative 2, right? So hence they said the values of the common ratio. Okay, so 3.2.3 says determine the value of R if R is greater than 0, right? So remember from here we are given the sum to infinity. So we can express this as sum to infinity is equals to A over 1 minus R, where our R should not be equals to 1. Then what is the value for sum to infinity? That's 54 over 19. And then here we have A over 1 minus R. Now let's go ahead and express this in terms of A, right? So we take this whole expression, multiply it with this fraction here. So that means we'll have A is equals to 54 in bracket 1 minus R over 19. So let's call this equation number 2, and then we'll call this one here that we just that we proved in 3.2.1 as equation number 1. Now, because both these expressions are expressed in terms of A, that means we can equate the two, because A in both these equations is the subject of the formula, right? So remember that's 30 over 19, 1 plus R, and the equation that we got previously there is 54, 1 minus R, and then we have 19. Now look at this. If we can just multiply it by 19 both sides, then the 19 will cancel, and then we are left with 30 over 1 plus R is equals to 54, and then I have bracket 1 minus R, right? Now if I cross multiply this, this is 30 is equals to 54, and then I have 1 minus R, and then 1 plus R, right? Now at this point, I can divide both sides by this 54. So I will have come over here. I will have 30 over 54 is equals to 1 minus r and then 1 plus r. Now looking at this, you can see that this is a difference of two squares. So we have 30 over 54 is equals to 1 minus r squared. Now let's take this over to this side. So we have r squared is equals to 1 minus 30 over 54. Right. Now if we do that, this will end up giving us r squared is equals to 4 over 9. Right. If you punch it in your calculator. Now to get rid of this square, let's square both sides. So my r is plus minus 2 over 3, but then remember the condition is my r needs to be greater than 0, so it needs to be positive. So that means my r is equals to 2 over 3. So just like that, I found the value for r, right? So that's how you expected to do that question. So also with this one, just take it one step at a time. It's similar to the question that we did before. And then this is just another chance for you to just try and understand the approach. Then question 3 says 3.1, prove that already we have discussed that if they gave you sum to infinity here, and then look, they also mentioned that this is a convergent series. So this is sum to infinity. So that means we must calculate the sum to infinity. But then here, this is just proving that this is a convergent series. So we do not have to calculate the sum to infinity, but we have to calculate r. So in order to calculate your r, you need to at least have 3 terms from this. So you can start by substituting in here 4 times 3, and then you have 2 minus 1, because you must substitute your k as 1. Then what is 4 times 2 minus 1? That's 1. 4 times 3, that's 12. Then if you were to do it for 4 times 3, and then now you'd substitute in the place of k, now you'd put 2, right? So that's 2 minus 2, it's 1, it's 0. Then 3 to the exponent of 0, that's 1. So 4 times 1 is 4, right? Then for the third one, you'd have 4 times 3, and then 2 minus 3, right? So if you do that one, you'd end up with 2 minus 3, that's negative 1. So that would be 4 times 1 over 3, which will give you 4 over 3. Now to calculate your r, that's T2 divided by T1. So your T2, that's 4, divided by T1, that's 12. So what is 4 divided by 12? That's 1 over 3. So yes, this is convergent because your r in this case is in between negative 1 to positive 1. Note that your 1 over 3 here is in between negative 1 and positive 1. So this is convergent because your r is an element of negative 1 to positive 1. Right. Then they say if the sum to infinity is that, and then the sum to infinity, that means it now gives you 2 over 9. So they gave you the value for the sum to infinity here. That means all you have to do is calculate the value of p, right? So the p that they gave you is this one. Now, for this one, remember, sum to infinity is expressed as sum to infinity is equals to a, and then we have 1 minus r like that, where our r should not be equals to 1, right? So, having to deal with that one, we understand that we are given here our 2 over 9. So we have to find the value of a. So we can find the value of a by substituting the p, because now it's saying start from p all the way to sum to infinity. So you can say 4 times 3 to the exponent of 2 minus p. So this will be your value for a. But then remember the r, we just calculated the r. Remember, this series here is the same series as that one. So our r is equals to 1 over 3, right? So now we have sum to infinity a. Can substitute the value of a as 4 times 3 to the exponent of 2 minus p. And then here we have 1 minus 1 over 3. But then our sum to infinity we've been given as 2 over 9. Right. So now let's calculate. We'll have 2 over 9. 4 times 3 to the exponent of 2. And then let's break down this one, 3 to the exponent of 2, and then 3 to the exponent of negative p, right? Then over, what is 1 minus 1 over 3? That's equal to 2 over 3. Now we can take this whole 2 over 3 multiplied with 2 over 9. So 2 over 3 multiplied by 2 over 9, that's equal to 4 over 27. Then here we have 4 times that. So what is 4 times 3 to the exponent of 2? That's 36, and then we have 36, and then 3 to the exponent of negative 2. Then let's multiply. We can multiply both sides by 1 over 36. So we are trying to get rid of that. So 1 over 36. So this gives us a value of 1 over 243, and then is equals to 3 to the exponent of negative p. Now we can express this in terms of exponents. So 243 is equals, and then shift fact, that gives us 3 to the exponent of 5. But then we know since it is 1 over 243, they should give us they should be 3 to the exponent of negative 5. And then it's equals to 3 to the exponent of negative p. Now look at this. The bases are the same. I can drop down the exponents. That's negative 5 is equals to negative p. Dividing both sides by negative 1, then my p is equals to 5, right? And just like that, you have found your value for p. So look at this question also. Give yourself time to understand the approach that I took in solving this question, and also try to solve it on your own, guys. Remember, in order to find this helpful and then productive, you have to be doing the question alongside myself, right? So that's it for the lesson today. Please keep on practicing. Practice more exam questions, those challenging questions, so that you stretch your mind to understand those questions and be able to accumulate those beautiful marks there. So with all that being said, guys, that's where we'll end our lesson. Please subscribe if you haven't subscribed yet. And if you have enjoyed watching this video, press the thumbs up button. If you happen to see any mistake that I did, or you want to understand something, you can just pinpoint the timestamp and then ask me the question that is relevant to the timestamp, and then I will be able to answer as soon as I see your comment, right? Then please share the link with your friends and classmates so that they may also find assistance. Remember, we are winning as a team.